My dear students, today we are going to discuss on the topic Mesomeric Effect, which is a special case of resonance. We have already discussed about resonance and its rules and everything in the previous class. Here we will going to discuss in detail about Mesomeric Effect. So let's consider first the example. CH2 double bond CH single bond CH2. This CH2 is carrying a positive charge. Whether resonance is possible here? Yes, because a conjugate system, a double bond, a pi bond, and positive charge in alternating position. Resonance is possible. It will comes here. Why? Because this carbon is having a vacant orbital and is not completed its object. So the resonance is possible, and this carbon will get a positive charge CH double bond CH2. Right? So object is possible and resonance is possible. So these are the resonating structure of this particular compound. Right? This is allyl carbonated. Okay. When a functional group attached to a conjugate system is carrying a lone pair or an odd electron. See example CH2 double bond CH carrying a vinyl chloride HCl. This is a vinyl chloride. A chlorine atom attached to an ethene. This group is called vinyl group. So vinyl chloride. Chlorine is having lone pair of electrons. Right? What will going to happen? This lone pair will comes here. And this will move here. Right? Because as we have already discussed that lone pair is more loosely held than a pi bond. So lone pair will first move to the conjugate system. So CH2 minus CH double bond Cl to positive. Again, what will happen? This will move here and this will come here. So CH2 double bond CH and Cl. Right? So these are the resonating structure. Similarly, when a compound is bonded with C double bond H, an aldehyde, what will happen? This will come here. So, and this will come here. What is the structure? This here, chlorine is the functional group, and here aldehyde is the functional group. So, CH2 plus CH double bond CHO minus. Right? CO minus. The negative charge is carried by the more electronegative atom. That is rule. We have discussed that in resonance chapter. There is a rule that the negative charge will be carried in a resonating structure. The negative charge will be carried by the more electronegative atom. So here the negative charge carried by the oxygen. So this is the resonating structure of this aldehyde. Okay. In these two cases, what is happening? Here, the lone pair is donated towards the conjugate system. This is the conjugate system, right? The pi bond is carrying, this is the conjugate system. The electrons are donated by the functional group towards the conjugate system. And what is here? The functional group, the aldehyde group, withdraw electron from where the conjugate system. This is known as Mesomeric effect. So Mesomeric effect is when a functional group which can donate or withdraw electrons from a conjugated system through resonance. So resonance is a mandatory case. Resonance is possible in that compound Only when there is resonance, mesomeric effect can happen. So when a functional group donate or withdraw electrons from a conjugated system through resonance is known as mesomeric effect. So we can say that the mesomeric effect is a special case of resonance. And also remember the point that all mesomeric effect can be considered as an example of resonance, but not all resonance a mesomeric effect. So all mesomeric effect is considered as resonance. All mesomeric effect can be considered as an example of resonance, but the reverse is not true, right? So for a mesomeric effect, resonance is a mandatory condition, and the second condition is that there should be a functional group attached to the conjugated system. That functional group has the ability to donate or withdraw electrons from the conjugated system. Okay. So we move on to the next part, types of mesomeric effect. There are just like resonance we have discussed plus or minus R. Here also mesomeric effect can be divided into two, plus M effect and minus M effect, or positive mesomeric effect or negative mesomeric effect, which is mainly depending on the substituent which attached to the conjugated system. If the substituent or the functional group attached to the conjugated system is having non-pair of electrons. For example, amino group NH2, nitrogen is carrying lone pair, OH group, oxygen is carrying lone pair, halogen, halates, fluorine, chlorine, they are carrying lone pairs. If the lone pair is there, it will be donated towards the conjugated system. As a result of that, electron density will increases in the conjugated system. So let's consider the example. If OH is there, lone pair is there carried by the oxygen atom. Okay. So this is a phenol. A benzene ring is carrying OH group. This lone pair is donated towards the conjugated system. This is a conjugated system. Pi bonds in alternating position. What will happen? This negative comes here. This will comes here. This will come here. This negative charge comes here. This will comes to this point. This negative charge will comes here, and this positive charge comes to the positive. So it will take the lone. So this is an example of plus M effect. That is, the electron density is moving towards the conjugate system, or the substituent group donate electrons towards the conjugate system. Resonance is the first condition, and functional group is carrying lone pair of electrons which donate towards the conjugate system, which is called positive mesomeric effect. So, as a result of this positive mesomeric effect, the electron density on the conjugate system will increases, right? The electron density will increase, which will facilitate electrophilic substitution reaction. What is an electrophile? The electron loving species. That is the substituent which is having a shortage of electron. Okay, which need electrons. So, this the presence of plus M effect on a substituent conjugate system, it increases the possibility of electrophilic substitution reaction. We will discuss this in later. So this is the plus M effect or positive mesomeric effect. So when we consider minus M effect, so we are going to consider minus M effect. Let's take an example and we can explain it. Here in the minus M effect, let's take nitro group. N double bond O and one coordinate bond with oxygen. This is a nitrobenzene. What will going to happen? This is the substituent. So this is the oxygen atom. This double bond, this electrons will move to the oxygen atom. As a result of that, nitrogen will get a positive charge, and the electron, the pi electron, will move away from the conjugated system. So there's a positive charge comes here, double bond comes nitrogen, O minus, and this will comes here, nitrogen, O minus, double bond here, positive charge is here. This bond will comes here. This positive charge comes here, and double bond here, O minus. This will come here, and this will come here. Again, double bond O. So we arrived at the final structure. So you can see that when a nitro group, when a substituent group is having double bond, or the substituent group is having a tendency to withdraw electron from the conjugate system, positive charge comes into the conjugate system and the electron density in the conjugate system decreases. Such type of mesomeric effect is called negative mesomeric effect or minus M effect. Like nitro group, cyano group, CN, aldehyde group, CHO, keto group, acid group, carboxylic acid group, or will facilitate minus M effect. What's the speciality of a substituent showing minus M effect? Let's see that due to the minus M effect of this nitro group, the electron density on the benzene ring, the conjugate system decreases. As a result of that, the positive charge delocalized in the ring structure, right? So the electron density which decreases, which means minus N groups or minus M effect facilitate nucleophilic substitution reaction rather than electrophilic. That is a nucleophile. A species is having lone pair or electron dense. So it will have a nucleus, a positive charge. So minus M effect facilitate nucleophilic substitution reaction, whereas plus M effect facilitate electrophilic substitution reaction. Right? So let's consider this example. This is called toluene. An alkyl group is connected to benzene ring. Resonance is possible by direct observation because pi bonds in alternating position. But whether this group has any plus M or minus M effect, no. Because alkyl group does not show any plus M or minus M effect because it does not carry any lone pair or double bonds or anything. Now we are moving to discuss a comparison between mesomeric effect and inductive effect. As you all know that inductive effect, we have already discussed about inductive effect in detail in my class. When an aliphatic chain, when an electronegative atom, say chlorine, is attached to the aliphatic chain, what will happen? The chlorine is possessed high electronegative than the alpha carbon atom. That is the first carbon to which it is bonded. As a result of that, the shared pair of electrons, in a covalent bond, the shared pair of electrons is there. This is a shared pair of electrons between chlorine and CH, carbon atom. The chlorine will attract the shared pair of electrons more towards itself. As a result of that, this electron will go there, this will move there, and this will go there. Okay. The pulling, the permanent movement of electron flow towards more electronegative atoms throughout the chain. This is called inductive effect. This inductive effect is applicable through sigma mode, right? Sigma mode. So we will compare the mesomeric effect, major differences between mesomeric effect and inductive effect. What is that? In inductive effect is applicable through sigma mode, right? It is because the flow through the sigma module, okay. But whereas in mesomeric effect, which is applicable to pi bond, right? The second application, the second difference is that how this inductive effect is formed, because the electron flow from the alpha carbon atom and which is permanent throughout the chain. As a result of that, inductive effect is first applicable to the alpha carbon atom and it is extend throughout the chain. So in inductive effect, alpha carbon is experienced the more. More pulling effect from the electronegative, right? But here, what about the mesomeric effect? This is due to the overlap of p orbitals. Overlap of p orbital means these are the two p orbitals. This get overlap. As a result of that, pi bond is formed, right? And the third condition is here restructuring happening. Restructuring of happen in mesomeric effect. How? Restructuring via delocalization. Restructuring via delocalization happen in the case of mesomeric effect. Whereas in inductive effect, there is no restructuring. No restructuring. Only electron flow towards more electronegative atom. Right? So these are the major differences. The first is mesomeric effect experience on pi bond, inductive effect experience on sigma bond. And mesomeric effect is occurred by the overlap of p orbital. Inductive effect occur on alpha carbon experiences more. Alpha carbon is experiences more than beta carbon and is extend throughout the chain, but the effect is decreases. The intensity of it decreases. So effect will be more of alpha carbon. The third is restructuring happening because due to resonance, the delocalization of electron, the compound, the actual structure of the compound is a hybrid structure or a combination of more than two structure. So since restructuring happen due to delocalization of pi electrons. Whereas in the case of inductive effect, there is no restructuring. Only the flow of electrons towards a more electronegative, right? And another thing is that this is the permanent effect because of the presence of electronegative atom. It is moving. Electronegative. It is a permanent effect. But whereas mesomeric effect is temporary because it's continuously moving. It will continuously. It's not permanent. It's continuously moving. So we can write as this is permanent. This is a permanent effect, whereas mesomeric effect is temporary. Because when the substituent is removed, it's also removed. But in the case of this combo, it is a permanent effect. The flow will be continuously moving towards the more electronegative, right? Now we are moving to discuss on the comparison between mesomeric effect and inductive effect using these examples. Which effect is more dominant over the other? Let's move into this case. First case, an amino group which is carrying nitrogen carrying a lone pair of electrons is connected to a conjugate system. In which direction the inductive effect will go? Due to the presence of an electronegative atom, a functional group, inductive effect direction will be here. So minus I effect because of the presence of electronegative atom. And in which direction the mesomeric effect? The lone pair is more loosely held than a double bond, so we go this direction. So this is plus M effect. That is, lone pair will donate towards the conjugate system. So plus M effect is in this direction and minus I effect is on that direction. Here we should remember that plus M effect, plus M effect always dominate over inductive flux. So in this case, the amino group which is attached to a conjugate system plus M, mesomeric effect is always dominate over inductive flux. Whereas there is an exceptional case is there, which is when a halide group, when a halogen, fluorine, which is bonded to a conjugate system, fluorine is very high in electron negativity. So the direction of inductive is here, right? The direction of inductivity is in this direction, and plus M effect is in this direction. But here, I dominate over N. So you should remember that when a halogen group, functional group attached to a conjugate system, inductive effect is dominate over mesomeric effect. This is an exceptional case. Okay, this is an exceptional case. In all other cases, mesomeric effect is dominant over inductive effect. Let's see this example. This is where a OH group is connected to a benzene. The meso, because of lone pair of electrons, this will come here. So plus M effect is in this direction, and plus I effect, minus I effect is in this direction. So M greater than I. Mesomeric effect dominate over I. Here also, because of lone pair, plus M effect in this direction, I effect in this direction, minus 18. So M greater than I. In this case, inductive effect is in this direction and plus M effect is in this direction. But here, when a halogen is present, I greater than M. Okay, inductive effect is dominate over mesomeric effect. When we consider benzene ring, there is no inductive or no mesomeric effect. So no effects because of the absence of functional group. When we consider NO2 group, what will going to happen? NO2 is having minus effect because NO2 we can write it as double bond O in NO2. So electron will move here, this will come here. So minus M effect is in this direction. So minus M effect is in this direction and plus A effect also in this direction. In toluene, there is only plus A effect, no mesomeric effect. No mesomeric effect because alkyl group does not show any resonance. In this case, the electron will come here. So mesomeric effect minus M effect is in this direction and I effect also in this direction, right? In the case of an amine group which is bonded to a benzene ring, this lone pair will come here. So plus M effect is in this direction. Minus inductive effect is in this direction. Here, M greater than I. Right? So we have discussed everything. So we have discussed everything here and we understood which is dominant over the other effect. Mesomeric effect is always dominant over inductive effect, whereas in the case of a halogen atom attached to a conjugate system, plus A effect is dominant over mesomeric effect. You should remember this case in solving questions.